Welcome to the Contractor School. Remember to take good notes on these things. We are in supply conductors. We kind of been going through this uh, little format here. We're still in services, service equipment, separately derived systems. We already talked about Ohm's law. We'll be getting into feeders and branch circuits here shortly. But we do want to get onto these questions that are regarding services. So this is kind of one of them. And notice it's requiring a bonding jumper on the service side. So let's go ahead and go to our code books, 250 102. It's a table, right? There's an article and there's also a table, okay? There's an article and a table. And I do want for you to put in your notes here this rule. I'm actually going to highlight these rules here so we can kind of write them in our notes now. I think it makes sense to write them in our notes now, or we could forget here, regarding these jumpers, okay? And there's rule number one. So if you could take the time to write that in your notes, I'd appreciate that, right? Rule number one: when you're sizing the supply side bonding jumper, use table 250-102, C1, right? And that's a very different table than the next table. When sizing the load side bonding jumper, use table 250-122. Okay, how about I write it in my notes? If I write it in my notes, maybe you'll write it in your notes, right? That's kind of how it goes. I understand, right? So to size the supply, I'm going to put that in caps, right? The supply side bonding jumper, right? We want to use table 250 102 C1. Okay, and to size the load side bonding jumper, use table 250 122. Very important, right? Two different tables. One is the supply side bonding jumper, and one is the load side bonding jumper, right? So this question is going to be talking about the supply side, okay? The supply side. But there's also, times where we would need a bonding jumper or what's called an equipment ground, right? That's the other reason for table 25122 is also used for equipment. Write this down. Grounding conductors. Equipment grounding conductors or bonding jumpers, right? On the load side, right? Big deal there, okay? So let's go and go back to the question. Let's go ahead and start getting this in our notes. Pretty simple, right? Not very difficult, but nevertheless, there's math involved. So let's make sure we don't mess it up here. If here we go, ungrounded supply conductors. So these are paralleled, right? In two separate raceways. What would be the minimum supply? Here we go. So the supplies, okay, are there. And then there's a supply side bonding jumper. So that's when we know we need the first table, 250-102, okay, between the 1,000 amp service and the steel frame of the commercial building. Assume the individual supply conductors for this installation are, the individual supply conductors are 250 kc mil. Well, if the individual supply conductors are 250 kc mil, and there's four of them, right? That's pretty easy math, right? Let's go ahead and put this in our notes, right? If there's four 250 kc mil conductors, right? Wouldn't it be the 250 kc mil times 4, and wouldn't that give us 1,000 kc mil, right? So that's in essence the supply side service if it was not parallel. But in this case it is parallel, right? Because these four are paralleled, right? Those four are in parallel. Okay, so in that case, we'd go to the table and simply look up the 1,000 kc meals. Let's go to the table. Um, Table 250-102C1 will give you a chance to get there. And once again, on the left side, we got the supply. You should highlight copper. Don't do aluminum because they never ask aluminum. If you over there in that column, if you do, they could ask aluminum, but it's not very common. So just highlight copper. I think it's wisest to highlight that column so you don't mess it up. Highlight copper and then highlight copper here, and then aluminum. You could even put a strike through it, put an X through it. You can still read it if you put an X through it. You just don't accidentally use it, right? Copper 1,000. You can see I went down here to 1,000, right? That would hit where the through's at in essence, right in there. And then at the same time, it corresponds with a 2-aught og, a 2-aught og bond or bonding jumper, right? Supply side bonding jumper. That's what it says up here. 2-aught og for a 1,000 kc meal service. Okay, pretty simple. So let's go ahead and put that in our notes then. So for the 1,000 kc meal service, using table 250-102, right? We size up to a 2-aught og bond ing jumper, right? 2-aught og bonding jumper, 2-aught og bonding jumper. Okay, so you can expect that question to show up on the exam. Okay, and let's go on to some more math here. Let's clear this page out. Let's take another quick peek at that question. Can't write everything down. There won't be enough time to write everything down. I just want to make sure we know the math because you'll be able to study this during the seminar and your home builds and everything, your software program at home. So you can read it as many times as you like, but I want to make sure we understand the math and why the math is what it is. Okay. Very good. So let's go ahead and move on to the next question. Given the calculated load of a retail store, calculated load. So this is a lot of calculations, right? Of a retail store is 58.4 thousand volt amperes, right? 58,400, right, volt amperes. What would be the required minimum size service conductors for this three-phase? That should ring a bell too. 122.8 volt service. Assume 75-degree terminations. It's interesting the question would say assume 75-degree terminations because what if it doesn't say that? You still need to assume 75-degree terminations. That's an important issue. Okay, so we're going to have to use Ohm's law here and make sure we don't forget the square root of 3 or the 1.732 down here. Not very difficult question. We already know Ohm's law. We should be able to knock this one out. Okay, so let's go ahead and put it in our notes. And we use Ohm's law, right? So wouldn't it simply be I is equal to P over E, right? I is equal to P over E is on the exam all the time in a big way, right? I is equal to P over E, but let's don't forget the square root of 3. Why? Because it's a three-phase question, right? So in this case, wouldn't it be our 58,400 volt amperes divided by the if we're going to do the total power, right? This is total power here, right? Isn't that total power, right? Wouldn't we also want to use the total voltage down here? Well, is the total voltage 120 or is it 208? It's 208, right? So when we put 208 volts here times, and then the decimal equivalent, right, of square root of 3 is 1.732, right? And since that's the case, we just multiply the bottom out. I think that makes sense to multiply that out first. I think most people like that format, right? 208 times 1.732, and then just get that number 360, right? 360.26. So 360.26 on the bottom or denominator, and on the top we still got our 58,400. And just take it nice and slow on these, you guys. You know, when you're doing your math, double check, triple check, quadruple check. because once you solve it, you don't want to go back and solve it again. I mean, that would be a big waste of time, and it's a time test. There's not enough time for that, right? So 58,400, make sure it's correct in your calculator, divided by 360.26, and then we get the 162. Now, that's kind of an odd number, right? What are we going to do with the 162 amperes? Well, I'm guessing I bet you know what we're going to do, right? With the 162 amperes, we need to take that on over to size it, right? We need to size the wire, right? So where do we size the wire at? We've been there once or twice, right? We're going to keep going there because it's used all the time on the examination. It's a big deal, right? Isn't it? Table 310, 15, or 310, 15, B16. This is a long one here, down here in the footnote, right? Always on the exam. We use that one to size wire, right? So let's see how fast you can get there. And by the way, if you can beat me to the code reference, because I got to type all this stuff in, and you just got to tab, you got to flip there, you should already be done. I'm still moving around here, trying to find it. If you beat me, then that's wonderful. Congratulations, okay? Once again, we got to be here all the time here. 162. Now, remember it said 75-degree terminations. And even if it didn't say we should use this column, slide down to the 162 that we came up with, and there isn't a 162. Well, what do? You size up, of course. Everybody knows that, right? Size up to the 175. Wouldn't that be correct? We size up to the 175 right there. And then over to the left when we get a 2-aught-og, right? So let's go ahead and put that in our notes then, right? For the 162, we're going to go ahead and size the wire using table 310, 15, B16. And the reason we want to write our notes, you guys, is to commit it to memory, right? When you connect your hand with your eye, with your brain, in my case with my voice, it helps me to remember, where these tables are at and how to use them, okay? So correct answer in this case, right, 2-aught-og. Let's take one more look at the question. Given the calculated load of a retail store is 58,400 watts, right? 58.4 kVA. What would be the required minimum size service conductors, right? The service conductors. Well, you need the ampacity first, right? And we did that. We got Ohm's law, right? And we calculated the amperage, the ampacity, and then we sized using table 310, 15, B16. They should be getting a little bit easier, right? A little bit easier. That table we use a lot, okay? A lot. Okay, let's go ahead and go to another question. According to the National Electrical Code, where are we here? Oh, and Article 210, and examples, Annex D, the examples in Annex D. And after applying the necessary calculations for a selected electrical service panel, what would be the minimum size service entrance conductors for the following dwelling? Okay, so now we're talking about a dwelling, okay? We're talking about a dwelling, so we've got to be a little bit careful here. When we're talking about a dwelling service, there's a table, an old table that disappeared a long time ago. Matter of fact, it's down here in this footnote. In the NEC 2011, which is going back a few years now, there used to be a table for the service, right? And what it said was, for a service rated 100 to 400, the service conductor supplying the entire load associated with one family dwelling, or the service conductor supplying the entire load associated with an individual dwelling unit in a two-family or multifamily dwelling, shall be permitted to have an ampacity not less than 80% of the service rating of the panel, right? Of the panel. So what we need to do in this case is know what the panel size is, and there it is. The service is a 175 service. Okay, so in this case, what we need to do is, we got just a tiny bit of math, right? It's not very hard, right? And then we're going to size this thing out, okay? This other article reference, you should go ahead and put it in your notes as well. Matter of fact, I'm going to go and write it in mine so you can write it in yours, right? Let me go ahead and get this notepad back up, and we're going to write down our notes here. Okay, so for this one, it makes sense to go ahead and highlight and then read through this whole section. Article 310.15, and it's kind of lengthy here, B7, 1. As a matter of fact, let's go find it real quick. Through 4. Right? 310.15, B7. I want to show you that real quick. So 310.15, B. I turn there in mind. You'll probably beat me there. That's okay. That's great. 310.15, and we're going to 310.15 B7. Kind of a hard one to find. Once you find it, great. We'll highlight it, and that way you can memorize this thing, read it 100 times if you have to. Make sure we got it in our head. We're getting close here. Past it. And we're going to 310.15 B7. And then we're going to B7-1. That's hard to find. Okay, I almost messed it up myself. Okay, there it is. And that's the sentence that we just read together. You can go ahead and highlight it once you find it. It's right before 310.60. And it should be on your page if you've got a book like mine, right? On page 149. Page 149, a couple inches down there, is the correct article reference, okay? And it's what we just read off, okay? And it's this article right here, 310.15b, 7-1, okay, through 4. Go ahead and read them all. What it says is the math that we have in our notes here. We're going to go ahead and put it in our notes, right? So we get the 175 amp service, okay, and we multiply by 83%, right? So isn't it 175 times 0.83? Sure, right? And then we just knock this thing out on our calculator, right? 175 times 0.83, and we get 145.25. 145.25 amps. Make sure you put a box around it as we talked about before. Why? Because these are answers. These are correct answers. Correct answer would be number 3, 145. Okay, so that one's not too tough, right? More stuff with math, right? According to the NEC, multiple clothes dryers. Oh, okay, I told you we'd need this one. So multiple clothes dryers. Let's go ahead and turn there. That's a table. Maybe you guys are already hustling your way over to the table, and that would be wonderful, right? Table 22054, if you recall. 22054. 22054, 56, I told you is also on the exam, but that's not the one we need this time. 22055 is on the exam, but not the one we need this time. And then here we go. 22054, right? I'm on page 73, and there's our table, okay? Now, in this case, there's multiple clothes dryers. So we need to see, there's kind of like a little formula, kind of like we did before, right? So it would be the number of dryers in this case, times the rating per dryer, times the derating factor, right? Sure. So in this case, let's take a quick look at the question here. Multiple clothes dryers permitted to be derated less than 100%. Therefore, if multifamily dwelling has 5, here we go, 5, that's important, clothes dryers, what would be the total calculated demand load for this installation? Well, but we don't know the nameplate. Doesn't say it, right? Doesn't say it. But remember, we read 5,000 watts of the nameplate rating, whichever is larger, right? So that's going to be in our code reference that we would have already highlighted right over here. Remember, we highlighted that earlier. 5,000 watts of the nameplate rating, whichever is larger. That's in 22054. So it means that we know that, right? And we see the question is 5 of them, right? This is pretty easy math, right? So, and the last piece of the puzzle would be the demand factor or the derating percentage multiplier for 5 ranges. Well, isn't it right there? I mean, that's pretty easy, right? That's pretty easy, right? So if we're to draw a little formula, you might say, let's go ahead and write it down here, right? I'll just put a little line here, right? And we're trying to calculate the total demand, right? The so let's put the dryer demand load, right, is equal to the number of dryers times the rate times the nameplate or 5,000, whichever is larger, right? Talked about that. Times the demand factor, right? So I know it's a lot of words, but it should make sense, right? The number of dryers is 5 times the nameplate rating in this case, because it didn't give us a nameplate, right? It did not. So then we got to use 5,000 here. Watts, sure. And then we multiplied times the demand factor. We did look that up. Let's just double check here. And it's still highlighted 85%. So wonderful. 85% or 0.85 is 85%, right? Okay. Then we go ahead and multiply this thing out here, right? This is just a very simple formula, right? It is a calculation, isn't it? Right? 5 times 5,000 times 0.85, and we just knock this thing out of the park. 21,250 volt amperes. Put a little box around it, put a star, make a tattoo, right? These are questions that might show up on your state examination. Okay, so let's go ahead and go on here, clearing the page, and move on to another important question for us to understand. Okay, ranges. Ranges are pretty tricky. If you go over 12,000, but if you don't go over 12,000, they're not that tricky. Let's go ahead and get into it. Ranges, range load calculations using table 22055. So using that table, pretty simple. We've been there once before when we talked a little bit about services, and that one didn't go over 12 kW either. So we're pretty close. Let's just slide down. There it is. Okay, table 22055, right, is always on the exam. Always, because it's kind of tricky. Now, if it's in this column, column A, less than 3,500 watts, no problem. If it's in this column, no problem, right? Column B. If it's in this column, still not a problem, as long as it's not over 12. This not over 12 is where the problem is. And I'd put a big old fat star by this thing, because if it's over 12, we want to put it over here on the side, right? Use the notes, use the notes, use the notes. When you go over 12,000, you have to use the notes, okay? Now in this case, let's take a quick look at the question, okay? It says, calculate the range load by applying the manufacturing accordance with the correct table and any applicable footnotes, given the installation contains the following, okay? It's a multifamily dwelling, okay? 120, 2.8, 4-wire feeder, interesting. It's 3-phase, that's interesting. Being a dwelling, right? And the number of range, now that's critical. That's critical, the number of ranges, and then the rating of the ranges. So that is critical information. The 20 ranges and the rating, the nameplate of the ranges is only 12,000. Now, that's okay, because this is not over 12. Now, as long as it's not over 12, we're good to go. And this column here is the number of kilowatts required. So what you do is you slide down to 20 over here on the left. I see it on the left here, right? Slide down to 20. And then over to the right, to the proper column, in this case, way over here, right? This column here is not over 12, right? So we line those two up and we see a 35, right? So wouldn't that be our answer right there? 35 kW, and we're done. Very, very easy question, okay? So let's go ahead and put that in our notes, right? So for 20 ranges at 12,000 watts, what's the total load on the service? Well, we use we used table 220.55, right? We looked up 20 units, right? We slid over to column C, and it lists very simply the correct answer. Put it back up here. 35. Okay. Right, 35. Right there it is. 35 kW. Right. 35 kW. Right there. Okay. So 35 kW. Let's go ahead and put that in our notes. Make sure we put a box around it. And that was for 20 ranges at 12,000. Okay, because we haven't went over 12,000 yet. Once we go over 12,000, then it does get to be, a bit of a problem. It gets considerably trickier. Okay, but that one, not too bad. Not too bad. Okay, now the next question is very similar, so let's go ahead and knock that one out. We might be able to fit it here on the same page. Let's go to the next question here. Calculate the minimum feeder range load by applying the demand factors in accordance with the correct NEC tables and applicable footnotes. Given the installation contains the following. Again, a dwelling, 12240, that's a little bit more standard, right? Single phase service. Here we go, 23 ranges. Here's the relevant information, right? 23 ranges at 3,000. Not too tough, right? Not too tough, right? So wouldn't we simply, let's go and put this one in our notes, actually. It makes sense to put it in our notes. Make sure we get a good note for all these things. So let's go and put a line there, right? In this case, we have a total of 23 ranges. Get this in your notes. At 3,000 watts. Doesn't sound too tough to me, right? It doesn't sound too tough. Pretty simple, actually, right? Because wouldn't it be the our formula would it be the load would be the number of ranges times the nameplate of the ranges times the demand or derating factor. Okay, so in that case, number of ranges is 23 times the nameplate rating 3,000. That's all given in the question. So only have to look up one thing, right? One thing is all we got to look up, and that is the demand for 23 units, right? So for those of you already at the table and go over to the right column, right? Wouldn't we go over to this first column? Now some people are going to go over this column, get the wrong answer, and that wrong answer will be one of the multiple choice wrong ones, as well as that 38. So that 38 would be wrong. Why? Because that's the wrong column. That one's between 9 and 12,000. This one here would be the wrong one. Excuse me. It's not 26 because we're not up in this range, right? 3,500. We're at 3,000, so it's less than 3,500 here. So wouldn't we be here? We'd have to line up this row with this column. We see 32% or 0.32. So in our notes, right, we just go 0.32 here, right? And then once we get 0.32, we go ahead and knock it out on our calculator. Let's send this one over the fence. 23 times 3,000 times 0.32 equals, and let's write that number down, very important number to write down, 2,080 watts, right, or volt amps, but that's also equal to, isn't that also 22.08 kW? I think that's the notation they're looking for in kilowatts. Okay, very important with the star. Very good. Let's put up the question one more time. Take another peek. And I appreciate your time. Thank you.